Hey there. So, if you're looking at colleges right now or just kind of trying to figure out your future, I am willing to bet you've had the term computer science shouted at you by parents, teachers, maybe a guidance counselor or two. But let's actually take a step back and demystify this material together in today's explainer. Because honestly, the reality of this field is absolutely fascinating and, well, completely misunderstood by most people.
I mean, if you're like most people, you hear computer science and instantly picture that classic movie trope, right? Someone sitting in a dark basement room, chugging energy drinks, and furiously typing glowing green code onto a black screen. But here's the truth. It's really not just sitting there building apps. It is actually the scientific study of computation itself. At its absolute core, computer science is the study of computation, information, and automation. It asks the really big fundamental questions, like what problems can we even solve using algorithms in the first place? What are the actual limits of computation? And when we do solve a problem, how can we do it efficiently? It basically spans across four main pillars. You've got theory, where we explore the boundaries of what's possible, then design, where we create those efficient algorithms, analysis, to measure exactly how fast our solution runs and how much memory it's eating up, and finally, implementation, which is taking those theoretical concepts and turning them into practical, real-world applications.
Okay, think about it like this, because this analogy is a total game changer. If computer science were medicine, then programming would simply be administering the medication. Let that sink in for a second. Programming is just a tool. It's a hugely important tool, obviously, and computer scientists use it to get the job done, but it is literally just one piece of a massive puzzle. Computer science is the entire study of how the systems work, why they fail, and how to fix them from the ground up. To really see where your own interests might fit, it helps to compare it to other paths in tech. So if you're a computer scientist, your focus is on the big theories. You're asking what can be solved and how efficiently. You are inventing things like brand new encryption methods. Now, if you're in programming, your focus is strictly on writing the code. You're asking, how do I build this specific software, like coding a mobile app or a video game? And if you're in information technology or IT, your focus is on managing the hardware and the networks. You're asking, how do I maintain and support this technology, like setting up company servers? When you break it down like that, it makes it so much easier to figure out which specific tech path actually aligns with your own personal goals. Once you realize how incredibly broad the field is, you start to see its major branches not just as boring college subjects, but almost like different superpowers you could acquire. Because you aren't just limited to one thing. You could specialize in algorithms, dive headfirst into artificial intelligence, or maybe master cybersecurity. You can even specialize in how computers physically work at the hardware level with architecture, or figure out how to design interfaces that people actually enjoy using, which is called human-computer interaction. There is a whole menu of paths here. Take artificial intelligence and machine learning, for example. This is all about creating systems that learn from data to make intelligent decisions. And I'm sure you know, it is the absolute hottest field on the planet right now. Why? Because it's the brain behind the chatbots helping you brainstorm your essays, the scary, accurate image recognition on your phone, and the self-driving cars that are hitting the streets today. But look, with all that incredible tech comes a massive need for defense. That's cybersecurity. As our entire world goes completely digital, protecting our systems isn't just a nice-to-have anymore. It is a high-stakes, 24/7 battle. Cybersecurity experts are essentially the digital bodyguards. They're defending against attackers trying to break in every single second of the day, working on encryption, authentication, and finding network vulnerabilities way before the bad guys ever do. Now, right about now, you might be thinking, okay, this sounds cool, but it's a bit abstract. How does this actually affect me right now? Well, computer science is the invisible bridge between complex math and your Friday night plans. You are interacting with computational concepts constantly, whether you realize it or not. Think about the last time you opened TikTok, intending to watch just one video, and suddenly an hour completely disappeared. We've all been there, but that wasn't an accident. Instantly, the platform's recommendation engines started learning your specific preferences based on your behavior. A machine learning algorithm actively updated your feed in real time to keep you hooked and show you exactly what you like. The exact same computer science principles are curating your Netflix binges and your Spotify playlists. It's all algorithms, actively working in the background. Or think about the last time you were running late and needed GPS. The second you type in your destination, a highly complex pathfinding algorithm just explodes into action. It analyzes real-time traffic conditions across thousands of possible roads. And literally in just 5 seconds, the absolute optimal route is displayed right on your screen. Calculating the fastest path from point A to point B through a chaotic, changing city, that is a massive computational triumph, happening right in the palm of your hand. But it goes far beyond your entertainment and your navigation. It's actively running the critical infrastructure of the globe. When you buy sneakers online, e-commerce cryptography protects your cash. Over in healthcare, medical machine learning is helping doctors spot diseases in x-rays significantly faster and more accurately than a human eye ever could. So these aren't just abstract theories on a whiteboard, right? These computational theories are literally keeping your money safe and saving human lives every single day. Okay, so we know it runs the world, but let's talk about you. Why does understanding computer science actually matter for your future? Well, whether you want a career in tech or you just want to completely bulletproof your resume for whatever comes next, grasping this field gives you an incredible edge. And yeah, we have to talk about the elephant in the room, the financial reality. The demand for these computational skills is exploding everywhere, and the pay definitely reflects that. Entry-level positions start incredibly strong, usually around $60,000 to $80,000 right out of the gate. But as you gain experience and specialize, it's very common to hit peak salaries well over $150,000 all the way up to $300,000 and beyond. But honestly, it's not just about the paycheck. Studying this stuff rewires your brain. You become an elite logical problem solver. You learn how to take massive, chaotic problems and break them down into small, solvable pieces. And that is a superpower you can take into biology, medicine, finance, art, literally anything. In a world where people are terrified of technology replacing them, this is how you make yourself completely future-proof. Because technology isn't going away, it is only becoming more central to our existence. So, to bring it all together, if you take one thing away from this explainer, keep this mental picture in your head. Think of the computer scientist as the inventor, the one designing the complex algorithms, proving what's mathematically possible, and figuring out the absolute best way to solve a problem. Then you have the programmer as the builder, the one taking that brilliant blueprint and actually coding it into working software. Both are absolutely essential, but they are fundamentally different roles in the tech world. Computer scientists are the true architects of the modern world. They're creating the underlying technology that's used by billions of people every single day. They invent the next major innovations that can fundamentally improve the lives of millions. So, knowing all this, and with these incredible tools at your disposal, and an entire world of complex puzzles waiting to be solved, what will you build?